Alright. Let us start our session by solving this problem from NEST 2009. Okay? Our lecture will be split into three parts. In the first part, we will solve Madras problems. In part 2, we will go to probability. And in part 3, which will be a lot smaller in terms of duration because I did not find any statistics questions whatsoever in NEST, but still we will be solving a few of them. Okay, alright. So question 1, suppose the system of equations ax plus y plus z is 0, x plus ay plus z is 0, and x plus y plus az equal to 0 has infinitely many solutions. The set of values of a for which this to happen is 1 minus 1 minus 1 2 2 minus 2 1 minus 2. This is a very simple problem. Okay, observe that the constant terms here are zeros. Now when we have a system of linear equations where the constant terms are 0, such a system is referred to as homogeneous system. Okay, and
so
one
make the determinant 0.
Correct. So the key part in this problem is to understand that when we have a homogeneous system, it will always possess a solution. Okay, 0 0 0. Now when it has infinitely many solutions, it means this matrix will be singular. Which matrix? A1 1 1 A 1 1 1 A. This will be a singular matrix, so this does not exist. Okay, so please solve it and tell me the values, and later on I will also tell you the speciality of that particular cubic polynomial that you are likely to get. Okay, so please do it and tell me the values.
So the answer is in between B and B,
Minus 1 2 or 1 minus 2.
because you'll get the cubic as a cube minus 3a plus 2. So the product of the roots should be 2.
A cube, what did you say? A cube minus
Cube minus 3a plus 2 is equal to 0.
A cube minus 3A plus 2 equal to 0. Okay. No, actually the product is minus 2, right? Okay, I think you said it right. Okay, the product is minus 2. Yes, so either B or D. Just check which.
Yes, sir.
Yes, so
Yes,
just check.
same cubic polynomial.
Same. Okay, so quickly check which one of them satisfies. I think minus 1 does not satisfy. I know, minus 1 cube minus 3 into minus 1 plus 2, does it give us 0? It doesn't. Okay, it does not give us 0, so the correct option is D. Although we can quickly verify whether D also satisfies or not. 1 clearly does, because if we consider the sum of coefficients, it is 0. So 1 is clearly a root. How about minus 2? Yes. Yes to minus 2, yes to 1. Now I have a question for you. This is a cubic polynomial, isn't it? This is a cubic polynomial, and the number of roots, or the roots that we have got, they are 1 and minus 2. Okay, so where is the third root here? Where is
Imaginary, sir.
नहीं नहीं नहीं, क्यूबिक है तो 2 रियल है, तो तीसरा कैसे इमेजिनरी होगा?
So that be a repeated root.
That will be a repeated root, correct. That will be a repeated root, but what will be the value of it? Will it be 1 or minus 2? So how to check it? It's simple. Look, I have told you that the sum is always negative of coefficient of x raised to n minus 1. Okay, I mean we can also find it using the product, but we are more comfortable with the sum. Now because there is no x squared term here or no squared quadratic term here, the sum will be 0, है ना? So if it is 1 minus 2 and the third root, or let's call it a3 now, the third root must be what? 1. Is it clear? So 1 is a double root here. Going one step ahead, if they ask you, instead of the set of values for this to happen, if they ask you the polynomial's graph, okay, if they ask you the graph of the polynomial or the roots in terms of the graph, then is it possible to plot the graph of this cubic polynomial? Suppose this is our x-axis. Which polynomial are we plotting? X cubed minus 3a plus 2. Now we know that for a cubic polynomial, as x tends to negative infinity, okay, f of x will also tend to negative infinity, and as x tends to positive infinity, f of x will also tend to positive infinity. So the graph's shape is clear as far as this is concerned, है ना? So let's now go to the roots here. This graph is going to intersect x-axis 2 times, right? This graph is going to intersect the x-axis 2 times. It will intersect at 1 and it will also intersect at minus 2. Correct? Of course you can apply the techniques of calculus to prove it, okay, but now because 1 is a repeated root, okay, we must show it like this. Understood?
Yes, sir.
Okay, now if it had been a question of 4 options where they gave you different cubics, their graphs, and they did not specify which one, rather they asked you to pick the graph whose intersection with x-axis are the roots. Now if they had given something like this, here minus 2 is the double root and 1 is the single root. Now this option would have been there definitely, but you need to select the one where 1 is the double root and not minus 2. Okay? That means arriving at this cubic polynomial is something that you need from matrices. After this you need to switch to functions, so that could possibly be a mixed concept question, wherein they will instead of asking you the set of values of a for this to happen is, they may say the roots of following curve or following function or equation, okay, so you can say the zeros of the following function, and in this there will be 4 curves given to you. Okay, there will be 4 curves given to you like this, and you have to pick the right one. Okay, so which one will you pick? You'll pick that one where 1 is the double root and that is positive. The double root is positive, so this is that, and then this is minus 2. Clear? That could also possibly be the question of one question. Acha, one more thing. So there are infinitely many points here. So if I take a value of a here, if I take a value of a here, let's say something 1.2 or something like that, what will be the nature of solutions? My question is, if suppose I take a value of x or a which is neither 1 nor minus 2, what could be the nature of the solutions? Will it have infinitely many solutions still, or will it have unique solution, or will it have no solution? Tell me.
No solution, sir, since it is not intersecting
नहीं 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 इसकी बात कर रहा हूँ मैं, होमोजीनियस सॉल्यूशन की बात कर रहा हूँ. ए का अगर 1 और -2 के अलावा कोई भी वैल्यू लिया तो सॉल्यूशन आएगा क्या नहीं, इसका ये पूछ रहा हूँ मैं. Yes, what do you think? Will it have a solution or not?
It will have, sir.
It will have, क्योंकि 0 0 0 तो हमेशा ही है ना. Irrespective of value of a, this system because being homogeneous, it will always have a solution. मतलब when it is neither 1 nor -2, it is going to have only 0 0 0 solution, but solution रहेगा. When it becomes 1 and -2, then the system will have infinitely many solutions. Have you understood this?
Yes.
Okay. Now just one last part about the problem. Although it's very unlikely that they will ask you this, but I just want to cover it right here. Suppose I take x as 1, oh sorry, a as 1. Suppose I take a as 1. Okay, suppose I take a as 1, then naturally I will get only one equation, x plus y plus z equal to 0. Okay, x plus y plus z equal to 0. And then you can clearly see that all I need to do is I need to pick 3 real numbers. Okay, I need to pick 3 real numbers whose addition is 0. That will serve as a solution. Okay? But suppose I take a as 2, or -2, sorry, a as -2. Suppose I take a as -2. Okay, can we express the solution as a set? Okay, let's see. -2, 1, 1, 1, -2, 1, 1, 1, -2. Now what I'm going to do is I'm going to reduce this in upper triangular form. Okay, because I know on the right hand side I've got 0 0 0, which means no matter which row transformation we do, interchanging, multiplying, subtracting, whatever, the column on the right hand side is going to remain 0 0 0. So it is enough to just continue with this. Okay, so what do you think we can do here? We can say R2 plus 2R1 and R3 plus 2R1. Okay, R2 plus 2R1, R3 plus 2R1, what will we get? Look carefully. 0 and 0, that's why we did that. Okay, now R2 plus 2R1, -2 plus 2, so 0. And this would be how much? R2 plus 2R1, so this will be 3. Oh, my bad. Wait. Sorry. Shouldn't have done that. Sorry. It's not R2 plus 2R1. It should have been. Wait. It should have been R2 plus half R1. Sorry. My bad. Although it would have still worked, but let's go to R3 plus half R2. Sorry. So this will be -2 1 1. Okay. Abhi R2 plus half R1, तो ये 0. Okay, am I correct now? Yes. Now let's go to the second element of R2. -2 plus 1 by 2, -3 by 2. Okay, and this will be 3 by 2. Now third row, R3 plus 1 by 2, so this will be 3 by 2 and this will be -3 by 2. Now is it clear, this part?
Yes, sir.
Yes, clear. Okay, now look here. R3 is going to be dependent on R2 because here R3 is -1 times R2. That means if I do R3 plus R2, I'm going to get zeros here, right? Which means our system of equations now boils down to only 2. And which two equations are there? 0x minus y plus z equals 3. ये कैसे आ गया? इस पे फोकस करो. Okay, focus on this one. 0x. Now even if I take minus 3 by 2 y plus 3 by 2 z equal to 0, अल्टीमेटली 0 ही है ना यहाँ पे, तो माइनस वाई प्लस जेड इक्वल टू 0 ले सकता हूँ मैं. इसका मतलब मेरा y क्या हो गया, इक्वल टू जेड. ठीक है ना. गो टू फर्स्ट, go to first. Okay, go to first. Can any one of you tell me what is the associated equation here with this? What would it be? Minus 2x plus y plus z.
plus z equal 0.
हाँ, अभी y को z डालो. So x equal to z आ गया. Which means we still get a solution. Okay, we still get the solution. And what would that solution be? X, y, z सब same है. So 1 1 1 into lambda, where lambda is any real number. ये उसका solution set हो गया. मतलब क्या? When we say infinitely many solutions, what exactly do we mean? For a equal to 1 we mean just pick 3 numbers which add up to 0. हो गया. For a equal to minus 2, pick identical x y z. Identical कोई भी चलेगा लेकिन सेम चाहिए. x y z तीनों सेम चाहिए. That will also produce infinitely many solutions. Have you followed this?
Yes, sir.
Yes.
Okay. Alright. So I think I have explored it a bit more than what was asked, but nonetheless, it's good to know because you never know what type of question can you expect in these competitive exams, right? Okay. We'll take a similar problem now. Okay, we'll take a similar problem now, but let me again highlight this. Okay, let me again highlight this. If you take any system of linear equations, now I may have told you this already when we were discussing theory, but just in case if you have forgotten or if you don't know, listen to me. If you take any system of linear equations, okay, only 3 possibilities exist. Can you list them? Unique solution, infinitely many solutions, and no solution. Apart from these 3, no other possibility exists. अगर है तो यूनिक ही है, यूनिक है या इन्फिनेटली मैनी है. अगर नहीं है तो नहीं है. Got it? Now students often get confused. They think like a quadratic equation which can have 2 roots, 2 unequal roots, different roots. A system of linear equations can also have 2 different solutions. Okay? But it automatically implies due to the property of linearity, अगर 2 है तो उनका एडिशन भी हो जाएगा. So it boils down to this case, infinitely many solutions. Okay, now this helps you in eliminating some of these options here. Okay, okay, now when it comes to homogeneous systems, please listen to me now. Now how do we characterize a homogeneous system of linear equations? अगर लीनियर सिस्टम को हाँ बोलो.
ax plus by equals c plus cz equals 0.
वो एक ही हो गया.
No, yeah, matrix for ax equals b.
ax equals 0. Homogeneous में, in homogeneous system by definition the constant terms matrix is 0 or null matrix. So for homogeneous, no solutions possibility does not exist. Why does it not exist? क्योंकि 0 0 0 0 हमेशा काम करेगा, है ना. तो होमोजीनियस के लिए 2 ही कैटेगरीज है, यूनिक, इनफाइनाइटली मैनी. दिस डज नॉट एग्जिस्ट or does not apply rather. Please raise your hands if you understand this. जीरो का नो सॉल्यूशन का पॉसिबिलिटी है ही नहीं होमोजेनियस के लिए. व्हाई इज इट नॉट देयर? इट्स नॉट देयर बिकॉज 0 0 0 0, well, if you take any unknown, all values of the unknowns to be zeros, they will satisfy. Okay, now let's come back to question 2, which is from next 10, and see if we can eliminate some of the options by just looking at this. ठीक है. If omega is an imaginary cube root of unity, then the system of linear equations 2x plus 2 omega y minus omega squared z 0, x plus y plus z 0, x minus y equal to 0, has only the trivial solution. Okay, has only one non-trivial solution, ऐसा नहीं है. Okay, if it has, okay, one more thing maybe I should have told you, homogeneous में अगर यूनिक रहा तो उसको ट्रिवियल बोलता है, ओनली फॉर होमोजेनियस सिस्टम्स. और अगर इनफाइनाइटली में रहा तो उनको बोलते हैं नॉन ट्रिवियल. ट्रिवियल मीन्स समथिंग विच वी कैन फाइंड जस्ट बाय ऑब्जर्वेशन विदाउट डूइंग एनी एनालिसिस व्हाटसोएवर. एंड वी नो दैट 0 0 0 को डालना का तो कोई बड़ी बात नहीं है, राइट? वी कैन इजीली रिकॉग्नाइज इट हियर. 0 0 0 0 0 0 0 0 है ना? ओके, सो कैन वी रूल आउट ऑप्शन बी इमीडिएटली? यस, बिकॉज ओनली वन नॉन ट्रिवियल सोल्यूशन, ये पॉसिबल नहीं है. If one non-trivial solution exists, all multiples of it will also serve as non-trivial solutions. Got it? Because see, if we have some combination which is working, if I multiply this by k, it will still going to, it will still be satisfying that, isn't it? Because right hand side is 0. So option B चला गया. ठीक है? Has infinitely many non-trivial solutions? Could be. Has no solution at all? ये भी गलत है. क्यों गलत है? Because this possibility does not exist for homogeneous systems. This possibility does not exist for homogeneous systems. Please raise your hands if you understand that. No solution at all possible है ही नहीं. 0 0 0 हो जाएगा. So now we need to decide whether it has a only trivial solution or has infinitely many non-trivial solutions. And to find that, because in this case the number of unknowns is equal to number of equations, we can form the square matrix of coefficients and answer the question based on the value of the determinant. 2 omega minus omega squared, 1 1 1, 1 minus 1 0. Okay, so let this be A. Find determinant of A. कितना आ रहा है? Yes.
So, for having a trivial solution, should a determinant not be equal to 0?
करेक्ट. मतलब ट्रिवियल सॉल्यूशन और यूनिक सॉल्यूशन का जो रिक्वायरमेंट है ना, ए इनवर्स एग्जिस्ट्स, वो वही है. गॉट इट? यस. सो व्हाट इज डिटर्मिनेंट ऑफ ए? थिंक इट विल बी 0. डायरेक्टली 0 को इक्वेट मत करो. वी आर लुकिंग फॉर इट. ओके, वी डोंट नो वेदर इट विल वर्क. So this part depends on your knowledge of complex numbers, that sum of complex cube roots of unity is 0. Okay, rather for that matter sum of any roots of unity is 0, starting from the square root. Okay, so determinant 0 है, so A inverse does not exist. So which solutions exist? Infinitely many trivial solutions, not trivial solutions. So C. A will not. अगर determinant 0 नहीं आता तो A हो जाता. Okay, so that is option C, has infinitely many non-trivial solutions. Have you understood this?
Yes.
Yes,
Others?
sir.
Okay, now if you want, we can continue with this problem and try to find the general form of infinitely many solutions the way we did for the previous problem, if you want. Otherwise we will go to next MCQ. What do you suggest?
I think we go to the next one.
Okay, so maybe you can try that. What is the homework? Try to find x equal to y equal to z equal to in terms of some parameter lambda. कई बार 2 पैरामीटर्स भी आते हैं, वो चेक करो. ठीक है. ऑलराइट. Question 3 from Nest 12. If cot theta minus 1 cot theta into cot theta 1 minus 1 cot theta inverse is alpha minus beta beta alpha, then alpha 1 beta 1 alpha 1 beta 0 alpha cos 2 theta beta sin 2 theta alpha cos theta beta sin theta. Please solve this. ये शॉर्टकट पता है ना, ए बी सी डी का इन्वर्स कैसे निकालते हैं? यस,
Yes, sir.
बताओ.
Yes, sir.
1 अपॉन ए डी माइनस बी सी इंटू
Adjugate of ABCD, मतलब DA minus C minus B minus B minus C.
Yeah.
Sign gets reversed.
हाँ, ओके.
Yes.
ठीक है, स्टार्ट. Yes. What's the update?
Sir, C.
C, okay.
C.
C, okay.
C.
Great. Yeah, C is indeed the correct option. Let's just explore it a bit. और
Yes, sir. C.
C आ गया ना? ओके. अच्छा, तो पहले ये बताओ कि डिटर्मिनेंट कितना है? कोसेक स्क्वायर थीटा आया होगा, है ना?
Yes, sir. Cosec squared.
ओके, जस्ट अ सेकंड. हाँ, ओह 1 अपॉन, ओके यस. सो इसको साइन स्क्वायर थीटा लिख सकता है. ओके इसको साइन स्क्वायर थीटा लिख सकते हैं. अभी इन्वर्स कितना आया, मतलब वो एडजॉइंट. ओके ये तो वही आएगा.
सेम आया इसी.
ओके करेक्ट. So it would be cot squared theta minus 1. अच्छा तो मैं अभी पहला ही लेता हूँ, cot squared theta minus 1. So it would be, yes, cos squared theta minus, correct, cos squared theta minus sin squared theta, because this has sin squared theta in the denominator, that will get cancelled. Correct. Cos 2 theta, तो alpha cos 2 theta हो गया, ये confirm है. Okay, so option C correct. हाँ, another interesting question. This is a multiple select question from nest 15. The trace of a square matrix X is defined as the sum of its diagonal entries and is denoted by TR of X. If A and B are two 3 by 3 real matrices, then trace of A plus B equals trace of A plus trace of B. Trace of AB is equal to trace of BA. Trace of KA is equal to K into trace of A, where K is a real number. Trace of A transpose is equal to trace of A, where A transpose denotes the transpose of matrix A. Now I will leave the verification of A, C and D to you. Okay, will you do that?
Yes sir.
They are all true.
Yes.
Okay, they are all true. ये तो ऑब्वियस है ना, A प्लस बी का ट्रेस A प्लस ट्रेस B, के A का भी ऑब्वियस है, और A ट्रांसपोज का A वो तो सेम है क्योंकि डायगोनल एलिमेंट्स डोंट चेंज व्हेन यू टेक द ट्रांसपोज. ओके सो लेट्स इन्वेस्टिगेट फॉर B नाउ. ओके तो कैसे करेंगे ये, कोई एग्जांपल ले लो. लेट्स से
आइडेंटिटी मैट्रिक्स.
नहीं, अगर डिस्प्रूव करना है तो काउंटर एग्जांपल चलेगा, प्रूव करना है तो well we have to take the general case and proceed.
जनरल मैट्रिक्स सर ABCD.
A11 3 by 3 है ना, तो ऐसा करना पड़ेगा आप लोगों को. A21 A22 A23 A31 A32 A33 B11 B1. I mean you can choose simpler notation, but I'm just being more formal here. B21 B22 B23 B31 B32 B33. Now pay attention. We are not required to multiply all of them. Okay, like we do 6 times, row 1 2 3 and with column 1 2 3, so that makes it 6, right? Or 6 or 9 times. But we're happy with diagonal elements only. Okay, we're happy with the diagonal elements, and what I'll do is I'll directly write down the trace now. Okay, I will directly write down the trace. So let us start with first row, first column. A11 B11 plus A12 B21 plus A13 B31. Okay, ये हो गया first row, first column. That means it will be the first element. It will be A11 of the product plus. Now go to second row, second column. A21 B12 A22 B22 plus A23 B32 plus. Now this is the central element, this is this element of the product. Okay, now we need to go to third row, third column. A31 B13 A32 B23 and and A33 B33. Okay, now let's find the trace of BA. What do you think, will it be equal? Check करेंगे, ठीक है, easy है. Now see, just for the sake of ease, what I'll do is I'll first write A and then I'll write B. Okay, so this will still be A11 B11 plus A21 B12 plus A31 B13. Now right here you begin to realize that they are indeed same because of the way these sums have been piled up here. Okay, because of the sums that you have piled up here, you see that B1 to A21 लेना ही है हमको. The only difference is it has come in second row second element addition for AB, but it has come in directly first row first column here. Okay, let's just complete it now. Second row second column, so A12 B21 A22 B22 तो कुछ चेंज नहीं करेगा पोजीशन. A32 B23 yeah, plus last one A13 B31 A23 B32 and A33 B33. तो सेम हो गए क्या? हो गए, तो B भी सही है. Please raise your hands if you understand that. Now let me ask you a question. If we consider any n by n matrices, will these results hold true?
Yes sir.
Yes, वो सिर्फ 3/3 हमको दिया है, वो जनरल भी प्रूव कर सकते हैं हम लोग, है ना. वही आएगा, वही यहाँ पे और एक एलिमेंट आएगा और यहाँ पे एक पूरा रो ऐड हो जाएगा. ठीक है, अगर 4/4 है तो. ठीक है, सो नो क्वेश्चंस विद रिगार्डिंग क्वेश्चन 4, नो डाउट्स. ये याद रखो, ट्रेस का इंपॉर्टेंट है, क्योंकि ट्रेस इज डिफाइंड फॉर एडिशन एंड इट इज कनेक्टेड टू द एडिशन ऑफ द ट्रेस. दिस इज नॉट द केस विद डिटर्मिनेंट्स, माइंड यू. Determinant of AB is determinant of A into determinant of B. No such identity exists. For determinant of A plus B, वो ये नहीं है. Okay. In general, not true. Okay, please remember that. ठीक है, all right. Next one. Okay, I think you people can handle this one as well. Let P and Q be 2/2 matrices. Then the identity P plus Q into P minus Q is equal to P squared minus Q squared is true if determinant of P is equal to determinant of Q. True if P or Q is the identity matrix. True if P or Q is the zero matrix. True if PQ is equal to QP. Multiple select question है ये from nest 17. बता.
Can you consider cases like specialized cases?
Yes, in fact you have to do that for B, C and D.
So we'll consider general case and from there we'll check for all these options.
जनरल से कर सकते हो. हाँ, P plus Q into P minus Q, it is actually P squared minus PQ plus QP minus Q squared. Now look here, if see also, so this basically gives you this part. ये null matrix होना चाहिए, तो D सही हो गया. But we must also take into consideration the facts that product of any matrix with null matrix and with identity matrix, those products always commute. In other words, PI and IP, they are same, है ना. And P0 0P, they are also same. So because commutativity is a special property possessed by identity multiplication and zero multiplication, B and C will also be true. समझ गए?
Yes sir.
Yes sir.
है ना, तो बी सी भी सही हो गया क्योंकि वो डी का ही स्पेशल केस है. तो व्हाट डू यू थिंक ऑफ ए? What do you think of A?
No, sir.
No, it's not. Okay, because determinant of P equal to determinant of Q does not necessarily imply that PQ is equal to QP. Okay, if you want you can take counter example, but I think this much is enough. Okay, cool. So A is not right. B, C, D are right. Okay, now let's go to this last one from Nest or from matrices. This is from 19. Okay, shift 2. Let P be a 3 by 3 real matrix. Let Q be half into P plus P transposed, where P transposed is the transpose of P. Then P is symmetric if RP R transposed is symmetric for a 3 by 3 non-singular matrix R. For every 3 by 1 matrix X transposed QX is equal to X transposed PX. Okay. C, X transposed SX is equal to X transposed PX for every 3 by 1 matrix X implies S equals Q, where S is a 3 by 3 symmetric matrix. D, P is symmetric if Q is equal to P. Acha. Now, quite often we are told this, that any matrix, square matrix of course, any square matrix can be represented as a sum of a symmetric matrix and a skew symmetric matrix. ये याद होगा, है ना? And that symmetric matrix is actually half P plus P transposed, and that skew symmetric matrix is half P minus P transposed. Hope everyone remembers this.
Yes, sir.
Yes.
Huh. Now we may have just applied this, as in found out the symmetric and the skew symmetric matrix, but in this case we have to use it. Okay, and of course it will be this one. Okay, तो इससे हमें यही लगेगा कि Q is symmetric. That's the result that we will use or may use in arriving at this, choosing the options. Okay, so let's go to this now. P is symmetric if RP R transpose is symmetric for a 3 by 3 non-singular matrix R. Okay, now if you want to prove that P is symmetric, it is enough to prove that P transposed equals P. Now what's given is R inverse exists क्योंकि वो non-singular है, and RP R transposed is symmetric, means RP R transposed is equal to RP R transposed transposed. Have you followed this? ये दिया है हम लोग को, है ना? RP R transposed is equal to RP R transpose transpose, and we want to prove that P is symmetric. So how to prove it? First of all, recall this property. AB transposed is B transposed A transposed. Use it here. Okay, use it here. So now look, I will treat A as RP. Okay, I'll treat A as RP, and I will treat B as my R transposed. So what would it be now? It would be R into RP transposed. Raise your hands if you understood how we applied that. Perfect. Apply this property once again. Tell me what will we write instead of that bracket.
P transpose R transpose.
Correct. So what have we got now? RPR transposed, sorry, RPR transpose equals RP transposed R transposed. Now we would make use of the fact that R inverse exists. Pre-multiply by R inverse and post-multiply by R transpose inverse. Club. Is option A correct? Yes. Have you understood this?
Yes, sir.
Any doubt in option A?
Sir,
Yes.
why did you multiply pre-multiply by R inverse and post-multiply by R transpose inverse?
Because we wanted to get rid of R at the end.
Okay.
See, what is our objective? ये प्रूव करना है ना हम लोग को. तो इसमें R का कोई रोल है नहीं एंड में, इसीलिए उनको एलिमिनेट करने के लिए इन्वर्स से मल्टीप्लाई किया. ओके, आई थिंक वी शुड गो टू डी नाउ. ये आसान है. And because it is in line with what we did in option A. In option A we wanted to prove that P is symmetric, and in option D also we want to prove the same thing. है ना? Okay. Now what is Q? Half P plus P transpose. Okay. Q is half P plus P transpose. Follow the rules of matrix algebra. 2Q is equal to P plus P transpose. QP सेम है. P करो यहाँ पे. Get P here. Got it. So D is also correct.
We could also use the property we discussed earlier, no?
Which one?
We said, like, if it's the sum, if it's
Yes.
1 by 2,
Yes.
because,
Yes. Smart. So Q is already symmetric, or rather Q is always symmetric. So if Q is symmetric, then Q has to be, then P must be symmetric. Yeah, good. That should have used that actually better. Okay. Okay. Let's come to B now. Okay, I think that's it for B. Yeah, okay. The same for every 3 by 1 matrix X transposed QX is equal to X transposed PX. Okay, for every 3 by 1 matrix X transposed QX is equal to X transposed PX. Remember, Q is half P plus P transpose. Okay, so how to prove this? Yes, can anybody tell me that?
Sir, we'll put half P plus P transpose in place of Q, and then cancelling X transpose extra from both sides.
नहीं यार.
Does that work?
कैसे कैंसिल करोगे? डिवीजन अलाउड है नहीं. और ये इन्वर्स, इसको इन्वर्स कैसे निकालोगे? 3 by 1 है ये.
Yes, sir, inverse noting.
हाँ तो टेल मी.
Sir, we'll take general case 1 3 by 1 matrix.
वो तो लेना ही है हम लोगों को. बट आई एम आस्किंग इफ इज देयर एनी अदर वे दैट यू कैन थिंक ऑफ. what we can do is we can start with Q. Okay, है ना? And now we can say it's X transposed P yeah, okay, X transposed P by X by 2 plus X transposed P transposed X by 2. Okay, and so at the end, what do we want? We want it as X transposed Px, isn't it? So if we set our objective as X transposed P transposed X equals X transposed Px, if we set this as our objective, we can easily prove, or I mean, if we get it, then B will be right, otherwise it will not be. Now, two questions arise. First is, how can we shift from this part to this? Look here, इसको हमको इससे इक्वेट करना है या चेक करना है कि वो सेम है क्या, है ना? बट I can always write this as X transposed Px by 2 plus X transposed Px by 2, लिख सकता हूँ मैं. Now this is there. So what remains to be proved or confirmed is this part. Forget 2 in the denominator. तो वो objective हो गया हमारा. Have you understood this part?
Yes, sir.
Okay. Now the second part is, or the second query is our operation of splitting it right here, is it justified? That's the second question that we must answer before we proceed. Do you think it is justified? Don't be under the impression that because it holds for numbers, real numbers, it should hold for matrices. It's not the case. ठीक है? So do you think this works? Yes or no? Please tell me. And don't say yes because I am saying yes. Counter it if you don't get it. Look, this is justified because of the way matrix multiplication is associated. Okay, so we can start doing it like this: X transposed P plus X transposed P transposed by 2 into X. Okay, this will be X transposed Px, okay, distributive property, plus X transposed P transposed X by 2. Hence it now becomes equal to this. ठीक है, वो justify किया है अभी, मतलब random steps नहीं किया वहाँ पे. Got it? Okay. Now tell me, what do we exactly need to prove here? Okay, see, P को symmetric नहीं ले सकते हम. वो let me complete. वो special case हो जाएगा. P equal to P transpose. We need to prove it for any 3x3 real matrix. बताओ. But what do we need to do? Assume P. Now in this case, A11 वो लिया तो भी चलेगा, लेकिन मैं ABC लूँगा क्योंकि एक ही मैट्रिक्स है हमारे पास. ठीक है? Okay, what is X? Sorry, X कितना है? X 3/1 है ना? X 3/1 है. Okay, 3/1 मतलब 3 rows 1 column. तो X को XYZ लेते हैं. Okay, now tell me, will you be able to find X transposed P transposed X? ये निकाल सकते हो क्या?
Yes, sir.
X, Y, Z, A, B, C, D, E, F, G, H, I, X, Y, Z. X transposed P X, Y, Z. Okay, can you do it? आ ही जाएगा ना, क्योंकि ये सिर्फ मैट्रिक्स मल्टीप्लिकेशन
Yes, sir.
सिंपल है, ये आ जाएगा तुमने
Both will be equal.
कर दिया क्या? ओके मतलब बिकॉज यू फील इट सो और यू डिड इट, वो करना है, वैसे लगता है इसलिए नहीं करना है ना?
No, sir. Yeah, I feel it because it's dot product.
करेक्ट करेक्ट करेक्ट, ठीक है, अगर करा है तो सही है, इसको क्वाड्रेटिक फॉर्म्स बोलते हैं, ठीक है। सो या बी इज ट्रू, चेक करो करते हैं, ठीक है, बी इज ट्रू। ना लीव सी टू यू, सी भी करेक्ट है, ओके, सी इज ऑल्सो करेक्ट, try it. You may use B. In the proof. ठीक है, I mean I could have done that but we're running out of time, so it's time to go to probability. C आएगा ना, चेक करो, नहीं आया तो मैं बताऊंगा क्या है C. X ट्रांसपोज SX is equal to X ट्रांसपोज PX for every 3/1 matrix X. अगर ये सही है तो this implies that S must be equal to Q, where S is the 3/3 symmetric matrix. Please try that, otherwise I will help you in doing that. Okay, cool. So that's it from matrices, for matrices from my side, and now we'll go to some probability questions. Oh, sorry. Okay, yeah, probability question 1 from NEST 2008. Question 2, let A be equal to Pn factorial plus 1, where Pn is the nth prime number. The probability that a number picked at random from the sequence a plus 1, a plus 2 up to a plus n is a prime number is 0, 1, n upon a, n factorial upon a. Okay, so how do you think you can solve this particular problem? My approach, as far as this MCQ is concerned, like picking up the options is concerned, we can pick a special case. We can pick a special case, and we need to be sure about it, as in the whichever prime number we are going to choose, it should give us options which are not equal, right? Only then the special case approach works. So just to remove the triviality of 2 and maybe 3, let's consider 7. Okay, let's consider 7 as our prime number. Okay, so 2, 3, 5, 7. So this will be P4. Agreed? 7 is P4, 2 is P1, 3 is P2, 5 is P3, and 7th prime number is 4th prime number is 7. ठीक है? 4th prime number is 7. अब A क्या हो गया? Tell me what is A? So A will be 7 factorial plus 1. Clear?
Yes, sir.
Okay,
Yes.
now consider this sequence. Okay. Observe that, okay, because n is 4, our sequence will have 4 terms only. Got it? Our sequence will have 4 terms only. Now tell me, is 7 factorial plus 2 a prime number? It's not. How to prove
Yes.
that? क्या prime number है?
No, sir.
It's not prime number because 7 factorial is 2k. It's divisible by 2. Same thing with this. 7 factorial is divisible, so you can write it as 3, let's say L plus 3. है ना? यहाँ पे this is divisible by 4, so 4m plus 4. This is divisible by 5. Okay, this is divisible by 5, so 7 factorial can be written as, let's say, 5n plus 5. So none of them is prime. All numbers are composite. All numbers are composite. Okay, so as far as picking up prime number is concerned, our answer is 0. And we know B, C and D can never be 0, because division of a non-zero number by another non-zero number can never lead to 0. Hence A is correct. Clear?
Could you explain the reason why you particularly chose 7 and not a number like 5 or 3?
Yeah, we could have chosen 2, 3 or 5 also. I just wanted to make it clear that, well, if that prime number is a bit bigger, we will have enough terms, enough number to convince someone कि अब हाँ ये ऐसा ही रहेगा. Like for example, for 2 if we go, it will be 2 factorial plus 2 and 2 factorial plus 3. Got it?
Right.
Okay, so 2 factorial plus 2 is 4. 2 factorial plus 3 is 5. Oh wait, this is not giving us oh sorry, this is first prime number. Okay, this is first prime number, right? So only this term will come. See, look, ये 1 है तो यहाँ पे n का value 1 है, so the first term itself will become the last term, and this is 4, which is definitely not a prime number. Clear?
Right.
I mean, we could have got it anyhow. If it is we are never going to get a prime number, it has to be 0. But I mean, just to get you the feel of how it really works, I considered 7. You could have considered 5 also, or even 3. ठीक है? Yes. In fact, there is a very popular proof. Okay. In fact, there is a very popular proof of the fact that there are infinitely many primes. So the proof works like this. We assume the contradiction, okay, or rather the opposite. We assume the negative. So say, let P be the largest prime. or let's say Pn. So what we now do is we consider the product of all prime numbers from 1 to n, and then we add 1 to this. Now this number is neither divisible by 2 nor by 3 nor by 5 nor by any other number, because for it to be divisible by 2 we must add 2, for it to be divisible by 3 you must add 3, for this to be divisible by 5 we must add 5. So because we add 1, we can say this is a new prime, or at least a number not divisible by any of the primes from P1 to Pn. P1 is 2, so there must be a new prime. And again include that new prime in this list, you will go on getting. Okay? So this is in the league of that, where you take the factor and then add 1 to it. Okay? Okay. Cool. Any doubt in this question?
No, sir.
अगर उन्होंने कंपोजिट पूछा होता तो आंसर बी आता. Make sense? Instead of prime, if they had asked composite, then it will be B. You know, all numbers are composite. Okay, B. Sorry, question 2, not B, question 2. This is from 2009. A fair die is thrown successively twice, and the sum of the two numbers S that show up is noted. For any subset T of 2, 3, 4 up to 12, let P of T denote the probability that S belongs to T. The smallest possible size or cardinality of T such that P of T is greater than or equal to 2 by 3 is 4, 5, 6, 7. Okay, so sum is S. Okay, sum is S. Now, what is T? T is actually this. Oh, sorry, not T. T is a subset of this. Okay. Yeah. Let P of T denote probability that S belongs to T. Okay, P of T denotes the probability that S belongs to T. Okay, the smallest possible size of T such that P of T is always greater than or equal to 2 by 3 is 4, 5, 6, 7. Okay. Now look here. Suppose we prepare the table. Okay, suppose we prepare this table. The die is fair. Okay, so all outcomes are equally likely. You know, all outcomes are equally likely. And what will be the corresponding probabilities? 1 by 36, 2 by 36, 3, 4, 5, 6, 5, 4, 3, 2, and 1. Okay. Now what is the probability of T being greater than or equal to 2 by 3? कैसे निकालोगे? they're saying any subset of T. Okay, so any subset means it could be a singleton set like 2 3 up to 12, and it could be a set containing 2 elements or everything. Now the wording here is a bit confusing. I think P of T has probability that S belongs to T. Okay, smallest possible size of T पूछा है such that P of T is greater than or equal to 2/3. मतलब T में कितने elements होने चाहिए? Okay, T में कम से कम कितने elements होने चाहिए so that whatever output that you have chosen that will be greater than or equal to 2/3. Yes. Okay, 2/3 is equal to 24/36. Now let us suppose we consider the outcomes which are more likely than the others. Okay, let's suppose we consider outcomes which are, let's say 7, 6, 8 and let's say 5, 9. What is the probability of 7, 6? 6, 8 का हो गया 10. ओके, और 5, 9 का हो जाएगा 8. Now this is actually 2/3. Okay, now pay attention. Smallest possible size of T such that P of T is greater than or equal to 2/3. अगर हम लोगों ने T को 5, 6, 7, 8, 9 लिया. Okay, 5, 6, 7, 8, 9 लिया. So what is the probability that S belongs to T? Okay, do you agree that it is 2/3 now? Yes?
Yes, sir.
Okay, now my question is could it be possible, because I've asked smallest तो हम कोई भी ले सकते हैं, मतलब ज़्यादा वाले की सोचने की ज़रूरत नहीं है. My main concern is, can we come up with a combination of only 4 elements where probability exceeds 2/3? I don't think
No, sir, it won't be possible because we've already added the largest probabilities.
correct. Yes.
So if we take smaller ones, then we'll have to use more elements,
Yes,
and then it would be greater than 5.
correct. Fine, so the
But at the
correct,
same time, since it's asking for the smallest, we'll have to take P of T should be equal to 2/3. So whatever we have got will be the answer.
okay, correct. So it's not A but it's B. Okay, like if we subtract that outcome, which one? Let's say we consider only these 4, it will be 20 by that. Take it, correct. All right. Okay, question 3. This question is from Nest 11. Let X denote the set of all natural numbers between 1 and 25. If a student selects a function randomly from the set of all functions from X onto X, then what is the probability that the selected function maps prime numbers to prime numbers? Now, there are 2 keywords here, or 2 key parts in the problem that we must understand. Look, when they say from X onto X, they specifically mean we want to consider the set of functions from X to X which are onto. meaning here we don't want the set of all functions. Rather, we want the set of all which functions? Onto functions. मतलब उसके रेंज में भी 1 to 25 ही रहेंगे. So no constant function, no function which has only 2 elements in its range, no function which has 3 or even 24. All 25 should be there. Have you understood this?
Yes, sir.
Yes.
अगर उनको ऑन टू नहीं कहना होता तो वो सिर्फ फ्रॉम एक्स टू एक्स ही बोलते हैं. वो समझ लो आप. अगर 2x होता तो फिर वो नंबर बड़ा हो जाता है ना. ओके, सो टेल मी हाउ मेनी ऑन टू फंक्शंस आर देयर? Can I say 25 factorial?
Yes, sir. 25.
If we start with 1, it has 25 options, and as we progress, the number of options available for that element to be linked, that will be reducing by 1. Okay, so 25, 24, and so multiplication applies. Okay, what is the probability that the selected function maps prime numbers to prime numbers? Please note, यहाँ पे identity function नहीं पूछा है. As in 3 need not get mapped to 3, it can get mapped to any other prime number, है ना? Which means we must now partition, okay, we must now partition our set X into primes and composites. So let's do that. A possible problem of Bayes theorem can also come on this, because that also requires us to consider partition प्राइम कंपोजिट में. ठीक है, क्योंकि वो बाय डिज़ाइन एक पार्टीशन बन जाता है वहाँ पे. ठीक है, ओके, composites and 1, because 1 is neither prime nor composite. Okay, how many primes are there? 2, 3, 5, 7, 9 नहीं आएगा, 11 आएगा, 13 आएगा. Looks like we need more space. 2, 3, 5, 7, 11, 13, 17, 19 and 23. तो कितने हो गए? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so there are n primes here. तो इसका साइज कितना हो गया? 16. ठीक है, okay. Now tell me, how many functions are there satisfying given requirement? प्राइम को प्राइम से ही करना है. एडिशनल रिक्वायरमेंट है कि फंक्शन ऑन टू होना चाहिए. तो प्राइम का प्राइम हो गया 9 फैक्टोरियल एंड 16 फैक्टोरियल. Raise your hands if you understand that. And if you haven't, please tell me, I'll explain it again. Has every...
Explain it again.
Yes, perfect. Look, suppose this is that set, okay, and this is the same set X, and you are defining an onto function from X to X, correct? So 25 arrows coming out of X from the left should go to 25 different elements from the X on the right, correct? Now if we have already partitioned the set, okay, if we have already partitioned the set and written primes separately, okay, यहाँ पर भी वैसा ही करना है हम लोग को. Yeah, okay, which means for the remaining numbers, say 1, 4, 6 till 25, we have only these many options available, है ना? So it's like picking one function from this and one function from this. Understand?
Okay.
And means
So
multiplication.
what you're essentially doing is both have to be onto, like whatever partition we have created, both have to be mapped, both have to be onto.
Yes.
So is that what it is?
Yes, because if primes get mapped to primes only, then non-primes must get mapped to non-primes. Otherwise, the condition of ontoness will be lost.
Got it.
Okay. Now, there's one more interesting thing about this problem, and it is about the way they have given up the options. Okay. I hope everybody understands that this is an alternate notation for NCR. Okay. Now, in our case, the required probability that a function maps prime to prime will be 9 factorial into 16 factorial upon 25 factorial. Where did 25 factorial come from? Ye. Okay, let's call it 1. Let's call this as 2, and let's say from it. So this is actually 1 upon 25 C9 or 25 C16. Okay, so which of the options is correct? C. Any doubt in this?
No.
No, sir.
Okay. Now the question would have changed slightly or maybe drastically, we don't know, if they had not given us the condition of onto. मतलब अगर उन्होंने सिर्फ यही बोला है कि कोई भी फंक्शन चूज करो, ओके कोई भी फंक्शन चूज करो, तो ये वाला पार्ट भी रिप्लेस होके क्या बन जाता? एनीवन विद द आइडिया हाउ मेनी फंक्शंस वुड दैट बी? 25 raised to 25
25.
है ना, सबको 25 ऑप्शंस रहेंगे. गॉट इट? तो वो हो गया. अगर ऑन टू का रिक्वायरमेंट नहीं होता तो ठीक है. एंड इवन हियर फॉर दिस केस हाउ वुड इट बी? It would be 9 raised to 9, okay, because 2 can get mapped to any of these 9, but for the rest, okay, for the rest of them there would be 25 options. Please raise your hands if you get that.
So can you explain this again?
Yeah. See, अगर कोई रिक्वायरमेंट नहीं डाला, ओके, अगर उन्होंने बोला है कि फ्रॉम x टू x इतना ही है,
अच्छा, on to नहीं. Okay.
मतलब ऑन टू नहीं है, मतलब उसका रिक्वायरमेंट ऑन टू नहीं है. आई मीन वी आर रिलैक्सिंग दैट कंस्ट्रेंट.
Right.
तो there are 25 elements, and for each element we have got 25 different options. So number of total functions would be 25 raised to 25. ठीक है?
Yes, sir.
And see, but for primes, what is the requirement? Selected function maps prime numbers to prime numbers. मतलब earlier we were saying if 2 gets mapped to 7, 5 cannot get mapped to 7 because of the onto-ness.
Yeah.
But now
it can be. So it will be 9 to the power 9.
exactly 9 raised to 9. But when it comes to the non-primes, as in composites and 1, they have no restriction whatsoever. Okay?
Yeah, right. So they'll be mapped to all 25.
Correct. ठीक है.
Understood.
So in the we could since we don't need to retain the onto-ness over here, we could also just consider just the prime case, so like 9 to the power 9 by 25 to the power 25. Is that possible?
No, but if you consider 9 raised to 9,
Yeah.
what are you doing with the other elements?
I mean, it doesn't necessarily. Okay. Okay. So all the inputs from X have to go somewhere. Is that what it's supposed to be. Okay.
Yeah, even I had that thought in mind, but then I realized कि बाबा वो 9 ही है तो बाकी के 16 कहाँ जाएंगे. हाँ.
So in the numerator, shouldn't it be 25 raised to 16 instead of 16 raised to 25?
Here?
Because there are 16.
Oh, correct. Sorry, my bad. हर एक मिनट, हर एक को 25 ऑप्शन से ऐसे 16. करेक्ट. My bad. Thank you. Also now you note that वो 16 raised to 25 नहीं है, 25 raised to 16. My bad.
Yeah, okay, sir.
Thank you. Okay. ठीक है. So that's it. Any other issues with this problem? No? Okay. Okay, question 4 from nest 12. A fair coin is repeatedly tossed. Let x be the event that we get at least 2 heads in 4 tosses, and y be the event that we get at least 3 heads in 6 tosses. Then x is a more likely event than y is a more likely event than x.
Option C, sir.
तुम ऐसे डायरेक्टली कैसे बताते हो कंप्यूट नहीं करके? गिवन डेटा इज इनसफिशिएंट. हाँ,
both events are equally likely because we are choosing a fair point. We can't say that if we get heads after 2 tossing, it is not definite that in the another tossing we'll get head.
No. At least I don't. I'm not, I would say, convinced with the argument. I mean, qualitative arguments are a good way, लेकिन only if we can do it quantitatively, I will definitely recommend you to do it that way. I'm not saying C will not be right. Let's find out. अब देखो, at least 2 heads in 4 tosses का मतलब क्या है? The random variable here is the number of heads, है ना? Number of heads. So what is the range of this? 0, 1, 2, 3, 4, 5. Sorry, 0, 1, 2, 3, 4. Sorry, 0, 1, 2, 3, 4. Now we want at least 2 heads. So 2, 3, 4. So we can say the probability that x is greater than or equal to 2 will be 1 minus probability that x is 0 minus probability that x is 1. Please raise your hands if you understand this. Okay. Others, did you understand that? Okay. Now what is the probability that x is 0? मतलब कोई भी हेड नहीं आया, एक ही इवेंट ऐसा पॉसिबल है, t 1/16. What is the probability that x is equal to 1? अब इसमें 4 आउटकम्स आएंगे, हेड फर्स्ट, हेड सेकेंड, हेड थर्ड, हेड फोर्थ, ऑल रेस्ट विल बी t's. So 4/16. Is it clear? Yes or no?
Yes, sir.
Okay.
Yes.
हाँ. Okay. Now let's go to this. At least 3. अभी इसको यहाँ पे लिखता हूँ मैं. And now let the random variable be denoted by y, number of heads again. तो अभी इसका रेंज कितना होगा? Oh sorry, instead of saying x equal to, I should have said x belongs to. Sorry, x belongs to. Y belongs to. Okay. तो यहाँ पे हम लोग को 6 तक जाना पड़ेगा. Okay, we need to go till 6. Now at least 3 means what? We want the probability that y is greater than or equal to 3. It's easier to find the probability of this being 0. 1, 2. ठीक है? So 6 है तो 64 रहेंगे आउटकम्स. ओके. Okay, here it will still be 6 by 64. Hope you understood this. 6 different possible outcomes are there where we will get only one head. Head first, head second, head third, head fourth, head 5, head sixth. Okay, now how much would this be? y equal to 2. मतलब अभी 6 पोजिशंस है हमारे पास, 1 2 3 4 5 6. इनमें से हेड कितने जगह पे आ सकता है, तो उसमें 6c2 लेना पड़ेगा हम लोग को. करेक्ट, 6. ठीक है, तो चेक करेंगे अभी. लेट मी डू इट हियर नाउ. 1 माइनस फ्रैक्शन 64 in the denominator, 1 plus 6 plus 6c2, 21 by 32. Pretty close to that. Okay, so this is 22 by 32 and this is 21 by 32. So the first one is greater. X is more likely than Y. Option A. Is it clear?
Yes, sir.
Yeah, so that's how it should be stored. ठीक है, अभी एक्चुअली ये प्रॉब्लम है ना, ये बाइनोमियल डिस्ट्रीब्यूशन पे है. अब मुझे पता नहीं आप लोगों ने वो सीखा है या नहीं. बाइनोमियल डिस्ट्रीब्यूशन वो था क्या एनसीईआरटी में इस साल? आई थिंक नहीं था. एनीवे, अब वो नहीं पता है तो भी हम निकाल सकते थे इन सब चीज़ों को. ये कॉमन सेंस है 62 और ये सब. अगले क्यों बाइनोमियल डिस्ट्रीब्यूशन पता होने का फ़ायदा ये है कि यू कैन डायरेक्टली पुट द वैल्यूज. ओके, बट नॉनदलेस इट्स एक्चुअली द सेम एज व्हाट वी डिड हियर. ठीक है, ओके. ओके, प्लीज टेक दिस क्वेश्चन एज होमवर्क. एंड एनीवे वी आर रनिंग आउट ऑफ टाइम. Okay, I'll do one thing. I will give you these questions as homework. Okay, there are 3 I suppose. 1 2, इसका आंसर B है. Okay, और ये भी, ये शायद आपको आ सकेगा. probability that sum of digits of n is equal to 24. तो इसके सॉल्यूशंस हम लोगों को निकालना है. ओके, x हैज़ टू बी ग्रेटर देन और इक्वल टू 1 एंड x y z आर इंटीजर्स. ये पढ़ लो, आ जाएगा आपको. ऐसा एक प्रॉब्लम आंसर एप्टीट्यूड टेस्ट में भी आया था. ओके, नंबर ऑफ इंटीजर सॉल्यूशंस. ठीक है, सो दैट्स इट ऑन प्रोबेबिलिटी. Are you guys okay if we solve one statistics question and I'll give you the rest as homework?
Yes.
Yes.
Now the reason is मैंने अभी तक statistics का कोई question directly नहीं देखा है नेक्स्ट में, लेकिन we'll take one. It's a nice question of binomial theorem combined with statistics. ओके, तो इसमें और भी क्वेश्चंस है, वो आप होमवर्क के लिए ले लो. नहीं आया तो मैं उसका सॉल्यूशन सेंड करूँगा. ठीक है, ऑल क्वेश्चंस एक्सेप्ट 1. ठीक है, ये जेई मेन का क्वेश्चन है. कंसिडर द डेटा ऑन एक्स टेकिंग द वैल्यूज 0 to 4 8 up to 2 raised to n with frequencies nc0, nc1, nc2 up to ncn respectively. If the mean of this data is 728 upon 2 raised to n, then n is equal to. इस प्रॉब्लम में दिक्कत ये है कि ऑप्शंस नहीं दिए. had they given us the options, we would have directly gone for the checking of the options. okay, or elimination method. First of all, let us recall the definition of mean. Let us call it x bar, or we can also call it mu. It is summation fi xi upon summation fi. Okay. So it's 728 here, 2 raised to n in the denominator. This is given. Mean is given as this. That's why we have done it. Okay. Now let's go to the right side. Summation fi xi upon summation fi. Now, if I wish to add the binomial coefficients, I know what this sum is going to be. This sum is going to be 2 raised to n. Agreed? Sum of binomial coefficients is 2 raised to n, तो ये cancel करेगा इसको.
Yes.
Now let's go to numerator. Let us go to numerator, which says nc0 into 0 plus nc1 into 2 plus nc2 into 2 squared plus nc3 into 2 cubed plus nc4 into 2 raised to 4, and the last term would be ncn into 2 raised to n. The moment you see powers of any number increasing with the binomial coefficients, subscript 1, 2, 3, समझ लो वो binomial theorem पर ही. Okay. Now, if you remember the proof in which where we prove that sum of binomial coefficient is 2 raised to n, you may recall that in that particular equation, or in that particular proof, we let a and b as 1. Okay, we let a and b as 1 there. Okay, now because the benefit of taking both a and b as 1 is that all powers of a and b will be 1. So वो binomial coefficients ही आ जाएंगे right side. In this case, there are two things that have changed. First, we have powers of 2 here. Okay, first we have got powers of 2. Second, first term is 0. Now that shouldn't bother us too much. Okay, consider the expansion of 1 plus x raised to n. What would it be? It will be 1 plus nc1 into x plus nc2 into x squared plus nc3 into x cubed plus ncn into x raised to n. अगर हमने x को 2 डाला, what are we getting? 3 raised to n equals 1 plus nc1 into 2 plus nc2 into 2 squared plus nc3 into 2 cubed up to ncn into 2 raised to n. Have you understood this? Yes?
Yes, sir. Yes, sir.
Okay, तो इसका मतलब क्या हो गया? ये जो सीरीज है, this series here, this exactly matches with not the whole of this but only this part, which then boils down to the following: 3 raised to n minus 1 must be 728. Therefore 3 raised to n must be 729. Can you tell me what is n?
Right.
ए 9 कैसे 6 आएगा? है ना, 6 आएगा. वो 9 का क्यूब है. वो 729 is 9 क्यूब, तो 3 स्क्वायर्ड का क्यूब 3 raised to 6. ठीक है. ओके, फाइन. So that's the end of today's session. Now we have one more mathematics session left, in which I am planning to cover questions which are based on school level geometry. Okay, that has been one of the prominent features of NEST, जहाँ पे वो लोग ऐसे कोऑर्डिनेट वाले क्वेश्चंस नहीं पूछते हैं, जैसे ट्रायंगल होगा, पॉलीगॉन, पेंटागॉन होगा, ऐसे वो एक है. And there are also some questions on integers and divisibility. I think one of you sent me a question yesterday.
Yeah, I did.
Yes, you did.
There are a lot of those actually, as divisibility ones.
Exactly. So I'm planning to take those two topics, maybe 2-3 questions per topic in our next maths class, and I think we have covered everything that is there. There will be a minor topics like permutations and combinations, but well, honestly, we don't have that much time. So,
So,
huh?
can we also do some questions on complex numbers?
कॉम्प्लेक्स का नहीं किया है ना. ठीक है, तो 3 टॉपिक्स हैं. लेट मी जस्ट पुट इट इन द ग्रुप सो दैट we can just 1 sec. CDP. Okay. First is school geometry. Second is divisibility. And third is, what did you say, complex numbers. Okay, fine. So our next session is on physics, which will be on Monday, on modern physics, which will primarily cover 4 chapters: semiconductor devices, atoms, nuclei, and dual nature. Okay.